Check one. Check one. Mhm. Right. Good evening, everybody. Uh, Today we are going to do grade 11, unit 8, which is heat changes associated with chemical reaction. One of the longest heading, kind of the shortest chapter. One of a short chapter, right? Before we start, confirm me from your end. Is the video, audio, is all the details perfect? All good? Yes, perfect, clear. YouTube side, perfect. All okay. Or all okay, right. Class students, you don't need to separately get the printout of the tube because already we have distributed the tube, acid bases tube. In that same tube, you have the energetics. There in outsiders watching this, yes, you need the tube for heat changes associated with chemical reaction. Long heading, no. So we made it shorter. The shorter form for this long heading is energetics. Heat changes associated with chemical reaction. The long heading, the short form is energetic. So that is this. This is your unit number 8. This is your unit number 8. Simple lesson, not a that kind of a tough lesson, but surely you will have questions from this lesson in your final O levels. Such a lesson. Simple, kind of different chemistry sections are there, different chemistry sections. Usually in chemistry, we don't talk about energy, but here we talk about energy. So kind of a different, but simple. Easily you can understand. What I want from your list, from the beginning until the end, listen very carefully. That's it I want from the beginning until the end. Listen very carefully. Towards the end, questions as well. Participate for the question. So from the beginning until the end, listen. Now this lesson, don't keep these lessons to study separately. We don't have time to separately study. Now February, you'll have the exam. Dates are already published. So we don't have time to separately study these kinds of lessons. These are simple lessons. No? Teaching itself, in class itself, you all study, put it to the mind, questions do with me, finish it. So in the class, whenever you study, you finish. Don't keep it separate, study on separate another. So separately, there are so many lessons already pending, and in future also you have lessons. So keep them to study separately. This lesson, don't keep separate. Now these 2 hours you are sitting here means don't make it waste. Please don't make it a waste. These 2 hours you work with me, put the things to the mind, memorizing things you finish off here. Questions I'll be giving homework as well. If can tonight itself stay, finish off the homework. Work like that. Hurry. Without any further delay, I'll start. Without any further delay, I'll start. Lesson heading is heat changes associated with chemical reactions. Heat changes associated with chemical reaction. Now, what does this heading tells us? Right. Lamai, already you all learned about chemical reaction. Now, during a chemical reaction, an existing substance undergoes a change. That's a chemical reaction. An existing substance undergoes a change. What kind of change? A chemical change. So an existing substance undergoes a chemical change during a chemical reaction. You already learned the existing substance is reactant, or there can be more than one reactants. New substance that is produced is product. Or you can call it products. If there is more than one product, products. So during a chemical reaction, reactants convert into products. Reactants convert into products. Reactants, it's a matter. Matter is undergoing a change during a chemical reaction. Matter is undergoing a change. Reactants are matter. So matter is undergoing a change during a chemical reaction. My question is it only matter that undergoes change during a chemical reaction? Is it only matter? Is it only a substance that undergoes a change during a chemical reaction? No. Not only matter. Remember, during a chemical reaction, there will be participation of energy there. During a chemical reaction, there will be participation of energy. I won't tell energy undergoes a change because total energy will be remaining same. Later on, to study deep, you can learn about it. I don't tell full energy undergoes a change, but energy will be participating during the chemical reaction. When reactants convert into products, there will be a participation of energy. Mainly what energy? Heat energy. about that participation of heat energy only, we study under heat changes associated with chemical reaction. So there is a participation of energy. I don't tell only heat energy. There can be any other type of energy as well. But mainly heat energy participates during a chemical reaction. How does it participate? How does it participate? See, listen. During a chemical reaction, two things can happen. Listen very carefully. During a chemical reaction, two things can happen. One, energy can be released. Energy can be released. Now, what's the energy we are discussing here? Mainly heat energy. So, during a chemical reaction, heat energy can be released. Or, during a chemical reaction, energy can be absorbed. Mainly, what energy we are discussing here? Heat energy. So, during a chemical reaction, there can be two things happening. Either heat energy can be released or heat energy can be absorbed. Either heat energy can be released or it can be absorbed, which means depending on the heat change associated with chemical reaction, you can divide chemical reactions into two. During a chemical reaction, if heat energy is released, you call that reaction as exothermic reaction. What reaction? Open the mouth and tell. Exothermic reaction. And during a chemical reaction, if heat energy is absorbed, you call it endothermic reaction. What reaction? Endothermic reaction. So during chemical reaction, two things happening. Either heat energy can be released or heat energy can be absorbed. If heat energy is released, you call it an exothermic reaction. If heat energy is absorbed, you call it endothermic reaction. Tell me, what are the two types of chemical reactions depending on the heat change? Exothermic, endothermic. Exothermic reaction, endothermic reaction. Exothermic, heat energy released. Endothermic, heat energy absorbed. Memorize only one. Best is memorize exothermic. Exothermic, heat energy released. Exothermic, you know, heat energy absorbed. Memorize one. Exothermic, heat released. Okay. It's very simple. Something like this. Now let's take inside this bottle, a chemical reaction is happening. Inside this bottle, a chemical reaction is happening. I'm putting two reactants together. They are reacting. When they react, heat energy is getting released. Let's take heat energy is released. If the heat energy is released, this is what kind of reaction? What kind of reaction? Exothermic reaction. Exothermic reaction. Let's take another reaction is taking place. Heat energy is absorbed. Then you call it what kind of reaction? Endothermic reaction. So those are the two types of chemical reactions depending on the heat change. Depending on the heat change. Right. Take the tute now. Heat changes associated with chemical reaction unit 8. Depending on the heat changes associated with chemical reaction, there are two types of chemical reaction. Onnala, I write the two types of chemical reaction. Write the two types of chemical reaction. Don't just write exothermic and keep. Fully write it. Exothermic reaction and endothermic reaction. Write the two types. Right. First going to exothermic reaction. First going to exothermic reaction. First going to exothermic reaction. First going to Daegu. Exothermic reaction. Now, what is exothermic reaction? During a chemical reaction, if heat energy is released, you call it an exothermic reaction. So what's the keyword for exothermic reaction? Heat energy released. Released is the keyword. If heat energy is released, you call it an exothermic reaction. We can write it using a general representation. We can write this using a general representation. Look very carefully, eh? Look very carefully. Right. Now, during a chemical reaction, what happens? There are reactant or reactants. It is converted into product or products. This is what happens during a chemical reaction. Reactants are there, they convert into products. Now, during exothermic reaction, what is happening? Heat energy is released. Heat energy is given out. Now, it is something like heat energy is produced during the reaction, isn't it? Heat energy released, heat energy given out. It means to us something like heat energy is produced during the reaction. Heat energy is coming out. Something is coming out. Something is coming out is something like a product. So during this reaction, heat energy is coming out, heat energy is released out. So heat energy is like a product. So in the product side, together with all the products, you also write heat. Why we write it in the product side? Because heat energy is released, heat energy is given out. Heat is like a product during the chemical reaction. So what happens during exothermic reaction? Reactants convert into products. Together with the product, heat is also released. Heat is like a product. So you write it in the product side. Okay. Now, for example, you take hydrochloric acid in aqueous medium and put magnesium, a stripe of magnesium into it. Into hydrochloric acid, you put a stripe of magnesium, solid state. Magnesium reacting with hydrochloric acid is an exothermic reaction, which means heat energy is released, right? What are the products formed? Magnesium plus hydrochloric acid. Magnesium chloride is formed. It dissolves in water, aqueous state. Hydrogen gas is released. Now, together with these products, what else is released out? Heat. Heat is also released out. So you write heat. So what does this mean? When hydrochloric acid and magnesium reacts, magnesium chloride and hydrogen gas are produced. Together with these products, heat is also released. So heat is like a product. You're getting out. You're getting magnesium chloride out. You're getting hydrogen out. And you're getting heat out. Actually, in O-level, we write it like this. But the correct way is, you have to calculate the amount of heat released. And let's take 2000 joules of heat is released. You first calculate the amount. Instead of writing just heat there, you have to write 2000 joules. That's the correct way. If it is 3000 joules, you write 3000 joules. If it is 5000 joules, you write 5000 joules. You calculate the amount of heat and write it there. But unfortunately, in your level, they don't expect you to write this value. Instead, you can just write heat. Heat is released. Okay. Now think opposite. If you see a chemical reaction like this, if you see a chemical reaction like this, product side, heat is released. Ehinang, this is what type of reaction? If heat is released in the product side, what type of reaction is this? They might ask that in MCQ question. They'll give heat in the product side and ask what type of reaction is this? Exothermic reaction. Only during exothermic reaction, heat is released. You write it in the product side. Write it in the product side. Okay. Sorry. Go to the tute now. Exothermic reaction. And exothermic reaction will first write what is exothermic reaction right there. During a chemical reaction, during chemical reaction, during a chemical reaction, if heat energy is released, if heat energy is released, if heat energy is released, it is the exothermic reaction. It is a exothermic reaction. It's a exothermic reaction. Again, I'll repeat, during a chemical reaction, if heat energy is released, it is exothermic reaction. Okay, no? Under that, in this general representation box, I want you all to write the main reaction, the general reaction, and write the example for that. Remember, writing state is a must. In this lesson, it's a must to write the state. You can't ignore the state. It's a must. Write with the state. I'll tell why it is a must later. It's a must to write this. So write this and write this in the box. Okay, done. Done. Right. The biggest question is why heat is released? Why heat is getting released? Why it is coming in the product side? Why heat is released? The reason. Now listen. Alamai, reactants, products, they are matter. They are matter. They are compounds or they can be molecules, they can be elements. They have bonds in them. In these bonds, energy is stored. In the bonds of the molecules, in the bonds of the compounds, energy is stored. Energy is there. There's a lot of energy, which means reactants, products, they all have energy inside them. Now, H2, it has some energy inside them. Magnesium chloride, it has some energy inside them. So these reactants and products, they have energy inside them. They have some energy. Now, reactants, they have energy. Inside them, there is energy. Products, they also have energy inside them. Reactants have energy, products have energy. Energy that reactants have is greater than the energy in products. Energy that reactants have is greater than the energy in the products. So reactants have lot of energy. Products need only little amount of energy, which means, can you see, when reactants convert into product, there is some excess energy remaining. Reactants have lot of energy inside them. Products need only a little bit of energy, which means there is a excess energy. There is some remaining energy. That remaining energy, that excess energy is only released as heat. What to do with that excess? Now, products doesn't need that remaining energy. It doesn't need that much of energy. So what can we do with that energy? We release it. That is released as heat energy. Now, for example, see, let's take during a chemical reaction, overall energy that reactants have is 2000 joules of energy. And overall energy that products have is 1500 joules of energy. Reactants have 2000 joules of energy. Products need only 1500 joules of energy. Tell me then, how much will be released during this chemical reaction? How much of energy will be released? And the reaction proceed, how much will be released? Everyone. 500 joules will be released. Why? This 500 is a excess. It's the remaining energy. What to do with this energy? We can't keep it in the product. We can't take and give it to the product. Products need only 1500 joules of energy. So the remaining 500 joules will be released. That is why during exothermic reaction, heat energy is released. Because reactants have more energy than products. Keep that in mind. Reactants have more energy, excess energy than the products. Okay. Memorize it like this. Now in an exothermic reaction, we write heat in the product side, right? We write heat in the product side. Product side we write heat. Opposite side have more energy. Memorize it that way. Product side we write heat, which means the opposite side more energy is there. Reactants have more energy. Product side you write heat, reactants have more energy, then products have less energy. Okay. That point is given to you. See, in exothermic reaction, reactants have greater energy than products. In exothermic reaction, reactants have greater energy than products. Underline or highlight that. Reactants have greater energy than products. Right. Now, in this lesson, we draw something called energy level diagram. In this lesson, we draw something called energy level diagram. What is energy level diagram? It's a simple graph we drew to represent the heat change during a chemical reaction. It's a graph that we drew to represent the heat change. We'll draw an energy level diagram for an exothermic reaction. Now, what happens during exothermic reaction? What happens during exothermic reaction? Reactant or reactants are there. They convert into product or products. During exothermic reaction, heat energy is released. So you write it in the product side, heat. Tell me who has greater energy out of reactants and products? Who has greater energy? Dingala, tell me. I wrote heat in this side. Who has greater energy? Heat this side can opposite side has greater energy. Reactants have greater energy. Products have less energy. Reactants have greater energy. Products have less energy. Right. How to draw an energy level diagram for this? How to draw an energy level diagram for this? Listen very carefully now. Now listen very, very carefully. If you understand this properly, for endothermic reaction, you can draw it by your own. And there will be MCQ questions with this, where you can't waste time to find the answer. Listen very, very carefully. Right. How to draw an energy level diagram for this? Very simple. Lamai, in an energy level diagram, we only have y-axis. That means vertical axis. Only the vertical axis, y-axis is there. Do we have x-axis? Do we have horizontal axis? No. Only vertical axis is there. Only y-axis is there. Right. There you go. I draw the vertical axis. Y. My y-axis is going to be the energy. Y-axis is energy. Only vertical axis, y-axis is there. Y-axis is going to be my energy axis. That is my energy axis. I take 2 points. One on top, one on bottom. Now, this is the energy axis. No? One on top, one on bottom. You all tell me using your mathematical knowledge. In y-axis, a point on top will have a greater value or a lesser value. Mathematically tell me in y-axis, when you go to top, your value is greater or lesser? Greater. That's simple maths, no? When you go to a higher point, value is greater. So 2 points are there. Here the value is greater. What value is greater? Energy. Here energy is greater. Here energy is lesser. Here energy greater. Here energy lesser. Now we are going to draw energy level diagram for this reaction, exothermic reaction. You all tell me in exothermic reaction, out of reactants and products, who has greater energy? Out of reactants and products, who has greater energy? Reactants have greater energy. So you write your reactants. You write your reactants on top. Who has lesser energy? Who has lesser energy? Products have lesser energy. So on bottom, you write product or the products. Reactants have greater energy. Products have lesser energy. So reactants I wrote on top. Products I wrote on bottom. Reactants are written. Products are written. Remember, in an energy level diagram, everything in this chemical equation should be indicated. Everything in the chemical equation should be indicated here. Reactants are indicated, products are indicated. Arrow is not drawn. So I have to draw the arrow. Now see, arrow goes from where to where? Reactants to the products. That's a general rule in any chemical reaction. Arrow goes from reactants to products. Reactants are here, products are here. Reactants to products, you draw an arrow. Reactant to product, you draw an arrow. Arrow is also drawn. Arrow is also drawn. Now, what else is remaining? Heat. What is happening to heat? Heat is released. Heat is given out. Heat is released. You write it like this. Heat released. See whether everything here is written here. Reactants, high energy. Products, low energy. Reactant to product, you have the arrow. Heat is released. This is a energy level diagram. Okay. Now don't misunderstand and think these lines are x-axis. What did I tell? No x-axis, no horizontal axis. These are not x-axis. We write this line so that on top of it we can reactants. We draw this line so on top we can draw we can write the product. Just to write it, we write the. Don't misunderstand and think this is x-axis. No, not x-axis. It is just to write the reactants on top. Is it a must to write energy high, energy low? No, you don't need to write. Okay. Huh. In your tute now, energy level diagram, a big box is given. What I want you to do is first divide the box into two. Divide the box into two. Listen, first listen. Divide the box into two. On the top, this part, write these things. On the top, write these things. Keep the bottom box empty. I will tell what to be written there. Start writing from the reaction. First write the reaction and then draw the energy level diagram. Try to work by your own. First write the reaction, then draw the energy level diagram. Try to work by your own. Don't go to memorize these things. These are logical things. I have taught you the logical part of it. So work it logically. Try to write by your own. Work. Once done, tell me done. Tell me once you're done. And when done, check whether everything is written the same way. Y-axis should be marked as energy axis. Reactants on top, products on bottom. Arrow from top to bottom here. Heat is released. done, 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 done. Right. I got so many dones. I'll change the board, eh? Right. But this is just a general representation. In the exam, you won't get this. What you will get an example. What you will get is an example. Now, we already know hydrochloric acid reacting with magnesium is an exothermic reaction. What are the products formed? Magnesium chloride, it will dissolve in water, so you have it in aqueous state. Hydrogen gas. It's an exothermic reaction, which means you write the heat in your product side. This is exothermic, you write heat in product side. This is an example reaction. Tell me, heat is written in this side, product side. So which side has more energy? Heat is written in product side. Which side we have more energy? Reactant side. This side we have greater energy. Here we have greater energy. Reactants have greater energy. Products have lesser energy. First, balance the reaction. Reaction is not balanced. You all balance the reaction. Tell me where what number should be added. Balance the reaction. Don't wait until I balance. I'm balancing. You practice by yourself. When you get a chance of balancing a reaction, balance it and practice it. Very good. This is how you see. One hydrogen, two hydrogen, one chlorine, two chlorine. One nitrogen, two hydrogen, one chlorine, two chlorine. 1, 1, 2, 2. So what I should write in front? What I should write in front? 2. One magnesium already equation balance. So 2 hydrochloric acid is there. Right. Reactants have greater energy, products have lesser energy. We'll draw the energy level diagram. In energy level diagram, only what axis is there? Y-axis. Y-axis is your vertical axis. Y-axis is your vertical axis. And that is energy axis. I take a point on top. I take a point on bottom. Top. Top has greater energy. Top has greater energy. Now tell me what has greater energy here? Reactants or products? Reactants have greater energy, which means you write the exact reactants here on this. What are the reactants? 2 hydrochloric acid is there in aqueous state. So should we write the state? Yes, it is a must. Even balancing you can ignore in the energy level diagram, but state is a must. Plus magnesium solid. Reactants have high energy. Who has low energy? Products. Products have low energy. So on bottom there, you write the products. What are the products we have? Magnesium chloride aqueous plus hydrogen gas. Those are the products. Those are the products. Reactants are written, products are written. Next, what? You should draw the arrow. Arrow is drawn from where to where? Reactants to products. These are your reactants, these are your products. From reactants to products, you draw the arrow. From reactants to products, you draw the arrow. Arrow is also drawn. What is remaining? Heat. Heat released. Draw arrow like this and indicate heat released. Heat released. Understood? Yes. Perfect. Now I told you divide the box into two. In the second part of the box, I want you all to write the example. Now try to work without looking. I mean, even in the example we wrote, previously we wrote an example here, balance the reaction, balance it and keep. Here we wrote a example, they are also balance the reaction and keep. Now here also in the example, balance it and keep. Write down. Try to work without looking. Try to work without looking. Try to work without looking. Work. So can you draw a straight arrow? No. Standard is you draw an arrow like that. That's a standard. There are some standards. Standard is that. Work by your own. And once done, tell me done. Done. Check whether the answer is correct. Check for each and every point there. Y-axis energy, reactants, product, arrow down, heat released. Okay. Hor. Right. That's it. Exothermic reaction done. Now going to endothermic reaction. Now going to endothermic reaction. Tell me what's the keyword? During endothermic reaction, heat is absorbed or released. During endo, heat is absorbed or released. Absorbed. Heat energy is absorbed. So the key word is absorb. Keyword is absorb. So what is endothermic reaction? During a chemical reaction, energy is absorbed. It is an endothermic reaction. In chemical reaction, if heat energy is absorbed, it's an endothermic reaction. What is exothermic reaction? During a chemical reaction, if heat energy is released, exothermic. Now let's take a chemical reaction inside this beaker. This is a beaker, just imagine the beaker. I do a chemical reaction inside this beaker. If heat energy is released, exo. If heat energy is absorbed, okay. Now exothermic reaction, heat is released. If heat is released, when I touch the container, what will I feel? Exothermic heat is released. When I touch, what do I feel? Container is hot. In exothermic reaction, heat is released. So when I touch it, I feel beaker is hot or the container is hot. Endothermic. Endothermic. Heat is absorbed. Heat is absorbed. When I touch the beaker, what will I feel? When I touch the beaker, what will I feel? What will I feel? Cool question mark. No, cool. That's the answer. What I will feel? Cool. Why? Lamai, from here, heat is gone. From the surrounding, heat is gone. Heat is gone. When heat is gone, what we feel? Cool. Here when I touch it, heat is coming to my hand. If heat comes, I feel it is hot. In endo, when I touch the beaker, heat is gone. From the surrounding, heat is gone. From my hand, heat is going out. From hand, if heat goes out, what I feel is cool. Remember, exothermic, we feel the container is hot. Endothermic, we feel the container is cool. Okay. So during endothermic reaction, heat energy is absorbed. Heat energy is absorbed. Now you all help me. I'm going to write a general representation. You are going to help me. General representation. Endothermic reaction, it's a chemical reaction. During any chemical reaction, reactant or reactants convert into product or products. Now think and tell me. During endothermic reaction, heat is absorbed. Something is absorbed for the reaction. That is something like the heat energy is needed for the reaction. Heat is absorbed and heat is like needed for the reaction. If something is needed, it is like a reactant or a product. If something is needed for a reaction, it's like a reactant or product. It's reactant. If something is needed for the reaction, it's something like a reactant. So in which side I'm going to write the heat now? Reactant side. Reactant side, you write the heat. Why? Heat energy is needed. Heat energy is absorbed for the reaction to proceed. In exothermic reaction, heat is released. You write in the product side. In endothermic reaction, heat is needed. Heat is absorbed. You write it in the reactant side. Now think, tell me, why you write heat in the reactant side? What's the reason? Who has greater energy now? Reactants, the product. Who has greater energy? Products have greater energy. Reactants have lesser energy. Reactants have less energy, not enough energy. For them to turn into the product, they need some more extra energy. Reactants have less energy. For them to become the product, they need some extra energy. That extra energy is the heat energy. Now, for example, let's take reactants have 1000 joules of energy. Products is 1300 joules. Reactants have 1000 joules of energy. Products are going to be 1300 joules. Ehenang, how much is the heat energy absorbed? How much is the extra energy that is needed? How much is absorbed? 300 joules. 300 joules extra energy is needed. Reactants have only 1000. To become product, another 300 is needed. Another 300 is needed. 1300, 1300. Harini, the logic is correct, no? The logic is correct, no? See, I wrote the heat in the reactant side. So opposite side has more energy. Heat was written in the reactant side, opposite side has greater energy. Reactants in the heat side, opposite side has greater energy. Logic is correct. Okay. If I draw an energy level diagram, see, reactant or reactants are there, absorbing heat energy, convert into product or products. Who has greater energy? Heat is written in the reactant side, which means products have greater energy. Reactants have lesser energy. We'll try to draw an energy level diagram for this. There you go, y-axis. Y-axis is the energy axis. I take 2 points, one on top, one on bottom. Now tell me, what comes on top? Reactants, the product. What comes on top? Reactants or product. Everyone. What comes on top? Who has great energy? Products have greater energy. Products are written on top. What comes on bottom? Of course, reactants. Reactants are written on bottom. Reactants are written, products are written. Arrow. From where to where we drew the arrow? From reactants to products. From reactants to product, you drew the arrow. This is reactants, this is product. Reactants to product, you draw the arrow. So now you draw the arrow upwards. Reactants to products. Exothermic reaction, you draw the arrow downwards. Reactant to product. So in exothermic, downward. Endothermic, up. Don't memorize it that way. Remember, in any chemical reaction, you draw the arrow from reactants to products. That is also wrong. What is missing? Heat absorbed. Heat absorbed. Heat is absorbed. So you write it this way. Heat absorbed. Understood? Logically understood this? Don't go to memorize. Logically understood this? Clear. Understood. Hurry, now go to the tute. Endothermic reaction. Under that, we'll write down what is endothermic reaction. During a chemical reaction, during a chemical reaction, if heat energy is absorbed, if heat energy is absorbed, It is an endothermic reaction. It is an endothermic reaction. It is an endothermic reaction. Right. Under that, write the general representation. Write the general representation. Example, no need to write any examples here. I'll give separately the examples for endothermic and exothermic. And under that, there is a point in endothermic reaction. This should be endo. Make it in endothermic reaction. Products have greater energy than reactants. In endothermic reaction, products have greater energy than reactants. Under that, draw the energy level diagram. Draw the energy level diagram. Don't look and draw. Work by your own. Once done, tell me done. Done. That's it, the initial section. That's it, the initial section about this lesson. Hurry. One more time, we'll revise. Now itself we memorize, finish it off. Hurry. Again, tell me. Chemical reaction. Based on the heat changes, you divide them into two. What are the two? Open the mouth and tell louder. What are the two? Exothermic reaction, endothermic reaction. Exothermic, heat energy released. Heat energy released means you write heat in the product side. If you write heat in product side, reactants have less energy, products have more energy. So that way you draw the energy level diagram. Endothermic reaction. Heat energy absorbed. Heat energy absorbed means heat is needed for the reaction. So it's like a reactant. So you write heat in the reactant side. If heat is written in reactant side, products have more energy, reactants have less energy. So that way you draw the energy level diagram. That's exo-endothermic. Okay. Next part. Next part of the lesson. Calculations. Now we are going to calculate the heat change happening during a chemical reaction. We're going to calculate in numbers. We are going to calculate how to calculate the heat change that take place during a chemical reaction. For that, we have a very famous equation. A famous equation is there. Important equation. What's the equation? Q equal MC theta. Theta. It's a Greek letter theta. Now in science, you will come across a lot of Greek letters. Alpha, beta, gamma, theta. A lot of Greek symbols you will be coming across. So this is theta. Q equal MC theta. Q equal MC theta. Now what does these letters stand for? What does these letters stand for? Q. Q is the heat change. That is what we are calculating. Q is the heat change that is happening during the chemical reaction. The amount of heat released or the amount of heat absorbed. Heat change is represented by Q. Simple M. Simple M stands for the total mass. Simple M stands for total mass. Tell me, what's the SI unit of total mass? What's the SI unit of mass? Kilograms. What's the SI unit of heat? What's the SI unit of heat? Heat is a energy. For any energy, SI unit is joules. C. Simple C. What does simple C stands for? Specific heat capacity. What does simple C stands for? Open the mouth and tell. Specific heat capacity. What is specific heat capacity? Next lesson, under the heat lesson, you will separately learn about specific heat capacity. Even though I tell the definition, you won't understand it. There is a definition for specific heat capacity, you can't understand it. In heat lesson, we'll be deeply learning about it. Specific heat capacity, the definition is this. The amount of energy needed to increase the temperature of a unit mass of a substance by 1 degree Celsius is specific heat capacity. Didn't understand? That is specific heat capacity. You won't understand the definition. But you can remember it like this. Specific heat capacity is something like how hard is it to heat a substance? How hard is it to heat a substance? If it is very hard to heat a substance, specific heat capacity is high. If it is easy to heat a substance, specific heat capacity is low. Now, for example, take rock. We'll take granite and petrol. Granite and petrol. Tell me, out of these two, which one is hard to heat? Granite, the petrol. Which one is hard to heat? Granite. Why? Because granite's specific heat capacity is high. Petrol specific heat capacity is low. So the specific heat capacity concept is something like how difficult is it to heat a substance. If the difficulty is more, specific heat capacity is more. If difficulty is less, specific heat capacity is less. For now, remember it like this. Later, in heat lesson, next lesson, I'll teach properly the definition of specific heat capacity. What does it mean? What's the unit of specific heat capacity? Two units are there. Two units are there. What are the two units? Joules per kilogram per degree Celsius. How do you read this? Joules per kilogram per degree Celsius. Or another unit is there. Joules per kilogram per Kelvin. How do you read it? Joules per kilogram per Kelvin. Joules per kilogram per degree Celsius or joules per kilogram per Kelvin is the unit of specific heat capacity. Remember their relationships. Remember 1 joules per kilogram per degree Celsius is exactly equal to 1 joules per kilogram per Kelvin. 1 joule per kilogram per degree Celsius is equal to 1 joules per kilogram per Kelvin. Now tell me 2 joules per kilogram per degree Celsius. How many joules per kilogram per Kelvin? 2. 10 joules per kilogram per degree Celsius. How many joules per kilogram per Kelvin? 10. 1000 joules per kilogram per degree Celsius. How many joules per kilogram per Kelvin? 1000. Numerically, they are equal. Numerically, they are equal. Remember that. And finally, what does theta mean? Theta. Theta means temperature change. Temperature change. Not just temperature. Temperature change. Theta is temperature change. You can have it in degrees Celsius or in Kelvin. We don't talk about Fahrenheit in our syllabus. So you can have the temperature change in degrees Celsius or Kelvin. And this is the best part. If your specific heat capacity is in degrees Celsius, then your temperature change also should be in degrees Celsius. If your specific heat capacity is in Kelvin, then your temperature change also should be in Kelvin. So whatever the unit that specific heat capacity carries should be the unit that temperature change also carries. If this is in degrees Celsius, this also should be in degrees Celsius. If this is in Kelvin, this also should be in Kelvin. That point keep in mind. Now, what's the connection between temperature change in degrees Celsius and temperature change in Kelvin? What's the connection between temperature change in degrees Celsius and temperature change in Kelvin? Remember, 1 degree Celsius of temperature change is exactly equal to 1 Kelvin of temperature change. 1 degree Celsius temperature change is equal to 1 Kelvin temperature change. 10 degree Celsius temperature change, 10 Kelvin temperature change. 1000 degree Celsius temperature change, 1000 Kelvin temperature change. 2000 degree Celsius temperature change, 2000 Kelvin temperature change. They are numerically equal. Again, I repeat, they are equal only in temperature change scale. Only temperature change in degree Celsius and temperature change in Kelvin are equal. Temperatures are not equal. Temperature in Celsius, temperature in Kelvin are not equal. Temperature change in degree Celsius, temperature change in Kelvin, they are equal. Change is equal. Change is equal, not the temperature values. You will learn it deeper, more deeper in your next temperature, temperature change. What's the connection? What's the difference between temperature, temperature? For now, keep in mind, temperature change in Celsius, temperature change in Kelvin, both are equal. Some people are wondering, why am I not putting degrees for Kelvin? Lamai, for Kelvin, we don't degrees. Only for Celsius and Fahrenheit we put decrease. Kelvin doesn't have decrease. Right? Those are the things. Now just imagine if the mass is given in grams and specific heat capacity comes in kilogram. If this is given in grams, can I do the question that way? With grams? No. If they give it in grams, I have to convert to kilograms. If mass is given in grams, you convert to kilograms. And of course, check whether specific heat capacity and temperature change. Those values are matching. Those units are matching. Hurry. I have a separate point about temperature change. Before that, go to the calculation section. Here we will be calculating the amount of heat change released or absorbed during a chemical reaction. Under that, a box is given. I want you all to divide it like this. Leave 2/3 of the space and separate 1/3 of the space. 2/3, 1/3. Right? 2/3, 1/3. In this 2/3 space, no need to now take a ruler and measure it. Just observably give a big space here, small space here. In the big space, 2/3 space, write these things. U equals mc theta. What does it stands for? Work. Once done, tell me done. Done. Okay, no? Shall I change? Okay. Or I have a small point about temperature change. And you give few more minutes, okay? Okay. Right. I have a small point about temperature change. Small point about temperature change. Now, sometimes in your questions, they won't give you the temperature change directly. Theta value, they won't give it directly. Instead, they will give the final maximum temperature. That's the final temperature. And the initial temperature. Without directly giving you the temperature change, they might give you the final maximum temperature and initial temperature. In such a case, how do you find out the temperature change? Final is there, initial is there. How do you find the temperature change? Temperature change is equal to final maximum temperature minus initial temperature. You subtract, you get the change. Subtract, you get the change. If I symbolically write down theta, temperature change is equal to final maximum temperature, TF, minus initial temperature, TI. Keep that in mind. So if theta is not given, guaranteed they'll give final temperature, initial temperature, subtract, you can find the theta. Okay. I mean, the remaining 1/3 space, I want you all to write this. Write it in the 1/3 space. Done. Okay. Done. So, right. Now, how will you get questions? Nothing big. These are very simple questions that you will get. See, let's take during a chemical reaction, a total mass of 2 kg is reacted. Specific heat capacity is 4 joules per kilogram per degree Celsius. Temperature change is 2 degrees Celsius. How much is the heat change? Mass is 2 kg. Specific heat capacity is 4 joule per kilogram per degree Celsius. Temperature change is 2 degrees Celsius. How much is the heat change? How to find out? Apply the equation Q equal mc theta. M value is there 2 kg. C value is there 4 joules per kilogram per degree Celsius. Theta value is there 2 degrees Celsius. Now these are scholarship questions, Nilamai. Just multiplication. 2 into 4 into 2. How much? How much? 16. Check the units. If you properly do, you get the units correctly. kg, kg to the power minus 1, cancel off. Degree Celsius, degree Celsius to the power minus 1 also cancel off. What is remaining? What is remaining? Joules is remaining. Kg to the power minus 1. Kg to the power minus 1 means division. Kg divided by kg cancel off. Degree Celsius divided by degree Celsius cancel off. You get joules. Now, can you understand why I told you to write all the units in the same way? If you write specific heat capacity in kilogram, mass also should be in kilogram. If you write specific heat capacity in Celsius, temperature change also should be in Celsius. Then only those two get cancelled off, you get joules. Okay, right. Now take your tute. In the tute, go to the question section. We'll solve some questions. Take the first question. Take the first question. All of you read once. Read the question once. Calculate the heat change occurred when an acid and a base of total mass 2 kg, total mass is given, is reacted in a closed system. Temperature change occurred during the reaction is 3 degrees Celsius. Specific heat capacity of water is 4200 joules per kilogram per degree Celsius. What are they asking? Calculate the heat change. Calculate the heat change. I'll write the values separately. First question, mass 2 kg, temperature change 3, specific heat capacity 4200. 2 kg, temperature change 3 degrees Celsius, specific heat capacity 4200 joules per kilogram per degree Celsius. What are they asking you? What are they asking you? Now apply the equation. Apply the equation. What's the equation? Q equals mc theta. M value is given 2 kg. Please write with the units. Multiply it by. Specific heat capacity 4200 joules per kilogram per degree Celsius. Theta value is how much? 3. Theta value is 3 degrees Celsius. Now, after this maths, up to here only we have science. After this, what we have is maths. Now do the multiplication. 2 into 3 into 42. 120. 6. 126 into 2. 251. 00. 25,100. 42 into 3, 120, 126, 126 into 250. Arne? 51 ne 2 ne 6 ne 252. 25,200 joules. 25,200 joules. That's the answer. Got it? Just values are given, do the multiplication. Yes. In your writing book, write down heat changes associated with chemical reactions. Question, do the question 1, then you all do question 2. Start working, eh? Now don't just sit and wait here. Don't just sit and wait here. You all work. You all train your brain. In case if they give it in grams, are you going to do the question with grams? No. You have to convert to kilograms. Keep that in mind and do. Right. Second question. Acid of mass 25 grams and base of mass 25 grams were reacted in a closed vessel. Acid 25 grams, base 25 grams. Now my acid is 25 grams, base is 25 grams. What is my M value? M is 25 grams, nothing total 50 grams. What is my M value? 50 grams. Why? What is M? Total mass. So total mass is 25 grams plus 25 grams, 50 grams. Given in grams, be careful. And the temperature change is 5 degrees Celsius. Calculate the heat change during the reaction. Specific heat capacity is 4200. Temperature change theta 5 degrees Celsius. Specific heat capacity 4200 joules per kilogram per degree Celsius. You apply the equation. Q equals mc theta. Always write the equation first. M Can I write directly 50 grams? Can I directly write 50 grams? No. I have to convert to kilograms. Tell me grams. How do we convert to kilograms? What we have? Divide by 1000. So what I will do is, I'll write like this. 50 divide by 1000 kilograms. I can write it like that, no? Instead of solving it and writing it in decimal 0.05, I can write 50 divided by 1000. If you want, you can write it decimal. Just like you, I also hate decimals. So to avoid decimals, I'll write it like this. 50 divided by 1000 kilograms multiplied by specific heat capacity 4200 joules per kilogram per degree Celsius. Temperature change 5 degrees Celsius. After this maths, eh? 1230 1230 3030 cancel off. 5 into 42 210 210 into 5 210 into 5 200 into 5000 10 into 500 sorry 10 into 550 1050. Check with the units. Kilogram per kilogram cancel off. Degree Celsius per degree Celsius cancel off. You get your answers in Joule. Raise the hand, go those who got this. Now don't ask me how the maths part came, man. That's maths. Right, good. Others, check and correct your answers. Can you explain it again? Well, understood how to convert gram to kilogram? 50 gram to divide by 1000. That is the kilogram format that I wrote there. Specific heat capacity, I wrote there. Temperature change, I wrote there. Use a calculator, type this and find out. Now, because after this, it's maths. Use a cal, type it and find, you'll get this answer. That is maths, and these 3030 cancel off. Go to the next question. Oh no, wait. First write this and finish it. Those are writing. Those are done. Just read the third question. Get ready. I have a small explanation, then you can start. Okay, no? Come to third question. During a certain chemical reaction, temperature change was 9 Kelvin. And you are getting 9 Kelvin. And total mass of the solution was 90 grams, given in grams. Calculate the heat change. Specific heat capacity is 900 joules per kilogram per degree Celsius. I'll write the data separately first. Third question. Total mass 90 grams. To convert to kilograms. Eh? Specific heat capacity 900 joules per kilogram per degree Celsius. Theta is 9 Kelvin. Now can you see grams, kilogram, we have a problem. Which means you have to convert grams to kilogram, divide by 1000. Same way, can you see temperature also you have a problem? This is given in degree Celsius, this is given in Kelvin. So just using degree Celsius and Kelvin, can I do the question? No. What I should do? I should convert the Kelvin to Celsius. Tell me, temperature change 9 Kelvin. How much in Celsius? How much in Celsius? Ah, 9 degrees Celsius. 9 degrees Celsius. Mass 90 grams, you divide by 1000. Start doing now. Is it possible to change the specific heat capacity to Kelvin? Yes, you can. I have taught that also. No? Even if you change this, you get the same value. No? 900 joules per kilogram per Kelvin. So any change is okay. But usually temperature change is easy. It's easy. Done. I'll work it out. Apply the equation Q equal mc theta. M. Mass is 90 grams. How to convert gram to kilogram? You divide by 1000. So 90 grams to kilogram, I divide by 1000 kilograms. Multiply by now. This one, some people are confused. This is what you are doing is 90 grams. You are dividing by 1000. Or if you want, you write it as 0.09 kilogram. No problem. Multiplied by specific heat capacity 900 joules per kilogram per degree Celsius. Specific heat, temperature change 9 degrees Celsius. Now maths. 1, 2, 3, 0. 1, 2, 3, 0 cancel off. So what you have is 9 into 9 into 9. That is 9 cube. 9 cube is 729 joules. Check whether the units are correct. Kilogram per kilogram cancel off. Degree Celsius per degree Celsius cancel off. You get the answer in joules. Raise the hand those who got it. Right, good. Those are done. Go to question 4. Done. Both done. During a chemical reaction in solution, heat change occurred was. Now heat change is given. All this time they were asking. Now they have given the heat change. Q is given. 5200 joules. And temperature change was 10 Kelvin. Be careful, they have given it in Kelvin. Calculate the mass of the solution. What they are asking is mass. Specific heat capacity of the solution is 200 per kilogram per Celsius. They have given it in Celsius. I'll write the data separately. 5200, 10, 200. Question 4. Q is given 5200 joules. Theta, theta is 10 Kelvin. Specific heat capacity 200 joules per kilogram per degree Celsius. What are they asking is mass now. Q is given, M is asked. Don't panic. Equation is the same. Q equals MC theta. Now Q value is given 5200 joules equal. M value is not given. You have to find it. I'll leave it as M. C value is given 200 joules per kilogram per degree Celsius. Theta value is given in Kelvin. Tell me 10 Kelvin. How much in Celsius? Convert to Celsius. 10 degrees Celsius. So that is 10 degrees Celsius. Now your job is, you need to find M. If you need to find M, you subject M. If you subject M, all these things go to the other side. Multiplication on the other side become division. So M is going to be equal to 5200 divided by 200 into 10. All these units will get cancelled off. Neither. Joules will get cancelled off with joules. Degree Celsius per degree Celsius cancel off. Kg to the power minus 1 when it goes to the other side become kg. Kg to the power minus 1 on the other side become kg. So you get your answer in kg. Or in a mass comes in kg. Now maths. What's your answer? 1230. 12020 cancel off. 52 divided by 2 is 26. 26 divided by 10 is 2.6. Answer is 2.6 kg. Raise the hand those who got this. Sorry, perfect. So done. Go to the fifth question. Done. Right. Acid of mass 50 grams and base of mass 100 grams. Ehinang, what's the total mass? 50, 100. Total mass is 150 grams. Arni? Total mass 150 grams. Both at initial temperature 30 were reacted in a closed vessel. Now initial temperature is given 30 degrees Celsius. Right. The final maximum temperature was 35. Final max is given 35. Right. That means theta is not directly given. Calculate the heat change, specific heat capacity of water 4200. Specific heat capacity 4200 joules per kilogram per degree Celsius. Onnalamai tell me. M is given, C is given. Theta not given. Then your first job is you need to find theta. Tell me how to find theta. How to find theta? Theta equal final maximum temperature minus initial temperature. Your final maximum 35 degrees Celsius. Initial temperature 30 degrees Celsius. How much is theta? 5 degrees Celsius. It's not a must to show this. I wrote it because this is the first question we are doing in this pattern. So I wrote it's not a must to show that. Now theta you know, M you know, C you know. How to find Q? Apply the equation. Q equals MC theta. M is 150 grams. Be careful, you have to convert to kilograms. 150 over 1000 kilograms. Multiplied by specific heat capacity 4200 joules per kilogram per degree Celsius. And your temperature change is 5 degrees Celsius. Your temperature change is 5 degrees Celsius. Now maths. One, 2, 3, 0. 1, 2, 3, 0 cancel off. 5 into 42, 210. 210 into 5, 1100. 1100 into 10. 1100 into 10. මෙහෙම එකක් එන්න බෑනේ. 210, 15. Five, 1, 3150. 3150. This much of joules. Raise hand those who got this. Right, good. Others, check your errors and correct them. 5 questions are done. 5 questions are done. Mark the homework. The remaining 5 questions. Question 6, 7, 8, 9, 10. That's your homework. I guess question 8. Yeah. Question 8. Superb logics have to be applied. Think and do them. Use your brain. Think and do them. There are some big logics you have to apply there. Try. So at least if you can't solve it, at least try. Question 8, 9, Hima. Try it. Trying is the most important thing. Don't wait until next week, 8:30 to try. 1 week is there. Take a time, sit and do this. Best is now itself. 10:30, no, still day is not over. No. Don't keep wasting your time. Now itself, maybe if you are not taking your dinner, go eat your dinner and start doing the remaining question and finish it off. Then done, no lamai. Today itself, this section is done. So try, today itself, try to finish this. Don't wait until the next week, right? And those who got struck with any of the previous question, again do this, redo this, again do the question, because surely you will have this kind of a question in your O-level paper. So this is something that you know that you will get in your O-level paper. So don't keep it. Right? Whatever we studied, try to revise once, one time, maybe read once, 5 or 10 minutes, read once, do the question. If you are struck with any of the previous question, do them once, do the homework. Okay. Next week, same time, I will continue with the homework and one experiment is there. We'll do the experiment and finish off. Okay. Understood the things today? Understood everything today? Yes, clear, very clear. Clear, well understood. Crystal clear, understood. I did the 5th and 7th. Okay, good. Right. Keep working. I'll meet you all again next week.